Hey everyone, let's start with question number 2, Digital Electronics, asked in GATE Examination 2025. A full adder and an XOR gate are used to design a digital circuit with inputs X, Y, and Z and the output F. As shown in the figure, the Z is connected to the carry in input of the full adder. If the Z is set to logic 1, then the circuit function as with X and Y inputs. So, before writing the solution, you should be aware of two important expressions. First is full adder and full subtractor. So, for full adder, your sum and carry out expressions are A XOR B XOR C in. C in is the input carry, and carry out expression is AB or BC or C in. For full subtractor, difference is A XOR B XOR B in. B in is the input borrow, and B out is A bar B plus B in A XNOR with B. You can also write A XNOR with B as A XOR with B whole complement. So let's go to the solution by redrawing the circuit. We have X as an input, Y and Z as an output. So you have to first understand what we are going to do is write the expression for full adder and then analyze the outputs of the full adder by looking at the corresponding inputs. So this is the full adder. This is written 2. As it is written 2, it means there are two outputs. We also know that the full adder has two outputs, which is one is the sum and one is the carry out. So F1 will be our sum and F2 will be our carry out. So we'll denote with F1 and F2 so as to avoid confusion that the full adder is going to behave is something else, because the entire circuit is now this. Your entire circuit will be now this, which is equivalent to a black box. So you don't know what is inside, and you have given the entire inputs X, Y, and Z. And here the question also says that for full adder, Z is connected to the carry in of the input of the full adder. So you have to remember this. This is C in, which is nothing but equals to Z. So first, now start writing the expression for full adder of sum. I am writing for you in bracket. F1 is A XOR B XOR C in. You can also denote A here, B here, and this is not the B here and C in. So this is A, B and C in. Now putting the values, A is nothing but X, B is nothing but Y XOR with C. This is an XOR gate, and C in is C. So you can simplify it. X XOR with Y XOR with Z XOR with Z. So you also know that Z XOR with Z returns 0, and X XOR with Y XOR with 0 is X XOR with Y. This returns your Y. This is your first expression. Now we have to go to find the second expression, which is carry out. Now it doesn't going to be a carry out, it is going to be a something, but for you I am writing this as A B B C in and C in A. So now putting the values of A as X, B as Y XOR with Z plus B, B is again B is Y XOR with Z, which C is Z plus C in is Z and A is X. Now little bit simplification, Y bar Z plus Z Y bar, so XOR can be written as this. Similarly, Y bar Z plus Y Z bar Z Z X X Y bar Z X Z Y bar and Y bar Z, and on multiplying this with this and this with this and operation, so it goes with 0 Z X. Now further simplification will X Y bar Z X Z Y bar Z Z X. Now this comes out to be X Z Y bar plus 1 and Y bar Z this X plus 1. Now this is XZ plus Y bar Z. Now in question, it is an important point. It says logic for Z is equals to 1. It does not affects the F1 because the expression does not contains the Z, but in F2 expression we have Z, so we have to put the value of Z X plus Y bar. So it is nothing but an expression for subtractor. Since it is a subtractor, or you can say specifically half subtractor have the expression for difference is X XOR Y, but the borrow out expression would be Y bar X. This is for Y minus X. So this would be your answer. You have to be careful for this way of doing, because sometimes it is asked for the nature of the circuit. So it is one of the good questions asked on the nature of the circuit. It does not say that the output should be a full adder. The entire circuit shows that it could be a full adder or full subtractor, but it is nothing but a half subtractor. Although just because the input is considered to be one of the input is considered to be 1, and only two inputs X and Y are playing the role to give the output F. That's what is asked in the question. X and Y as the input, set Z as logic 1. So your answer would be option B, subtractor.